Hello, everybody. I really appreciate all the hard work you've been doing. This week, we're going to do an introduction to arrays. You have used two-dimensional arrays before. You have learned about array lists. Arrays are a one-dimensional version of the two-dimensional arrays you already know about. Let's pretend that you don't know any of that and just do it all from scratch. So the reason why you want to use arrays is the same as for array lists. It's because it's easy to store and manipulate huge lists of values. So instead of creating 7 variables like I'm doing here and assigning values to them individually, the syntax there at the top shows you how you can both create and initialize an array, which is like a list of values all in one line. And then the way that you access them for array lists, you'd use the get method. So you'd say list.get location 0. Here, the syntax is shorter. So you'd say list and then use square brackets. And the square brackets mean access the array at a particular value. So list 0 would be the first value in the array. List 1 would be the second value in the array. So you can think about, just like for array lists, you can think about these as a numbered sequence of lockers, each of which stores a value. So here are all the variables, but you don't know what values are in there until you actually access them. And this is how you would access each one. You use the name of the array, which is list, and then the index, which is the location number in the square brackets. Pretty much every programmer I know has this picture in their head whenever they're thinking about listed data structures. So it could be arrays, could be array lists. The variable list refers to the entire list of variables, but then the way that you access each one, as I said, was with these square brackets. The values in the array are called elements, so you might say loop over the elements of the array and add 1 to each. The location numbers are called indexes or indices. So we're about 30 seconds from writing some code here, but I just want to emphasize that the individual elements of an array work just like variables because they are, in fact, just variables. So we already got this part. Instead of creating a bunch of variables separately, you can say int bracket. The bracket is part of the data type, and it means array here isn't a single int. It is an entire array of ints. But the data type itself doesn't say how long the list is. To know how long the list is, you actually have to create one. So here's new, which you might recognize as being similar to how you invoke a constructor. And then int is the data type for what kind of variable is each element in the list. And then the number inside here is the total number, is the total length of the list, the total number of elements. This is a big difference between arrays and array lists. Array lists, you can dynamically add and subtract things, so the list will grow and shrink. Arrays, you have to create them of a fixed size to begin with, and then you can never change them after that. You can save values into the variables, and you can overwrite the values, but you can never delete them, and you can never make the list longer unless you make a completely new one. But just to continue what I was saying, here on the left, you could see things you might do with an int variable would be store the number 3 into it, test to see if it's equal to 5, take the value, add 1, save it back inside that same variable, and then print it. You can do all of those exact same things. The syntax is exactly parallel using an array, except instead of having R is the name of the whole list, you would say R element 0. Or the element at index 0. And this whole expression here refers to a single variable. And so you can put it inside a statement of Java wherever you would think about having a regular variable. So you can save 3 inside location 0. You can check location 0 if it's 5. You can take location 0, add 1 to it, save it back inside location 0, and then print what's at location 0. Okay, so let's practice with some of these things just to get the syntax under your fingers. The syntax for creating an array is you have the data type for what kind of variable you want the array to contain, and then brackets are the square brackets say that we're making an array of those things. Then you have the variable name. That's declaring it. If you also want to initialize it, you'd have an equal sign, say new the data type, and then how many variables. So for example, int bracket nums equals new int 5 means we're creating an array whose length is 5 to store ints. And the indexes always start at 0. So if you have something whose total length is 5, the last index is going to be 4. It's always one less than the total number because you're starting your counting at 0. Okay, so let's try it. So if you want to follow along, please go ahead. Go ahead and create an int array of length 1000. You can name it whatever you want. Okay, here we go. So we do int brackets. I'm going to call it my array equals new int and then 1000. Pretty good. Try this one. Create an array that will hold 300 strings. Okay, so in this case, we'd type string, bracket, bracket, meaning an array to hold strings. I'm going to call this names, and then new, string 300. There we go. Okay, you might wonder what is inside all of these variables when we first create them. Let me show you something that you would want to do, but is unfortunately not going to work. You would hope that if you just displayed the name of your array variable, it would show you what the array contains. That is, in fact, not what happens. Here is what happens. It is running the wrong thing. Here we go. So you see that what it actually displayed was this. This is the memory location where your array has been created. That is not helpful for you to know about. So what you can do, there's two things you could do. You could loop over the array and display each thing yourself, or a little bit faster is say arrays.toString. Arrays.toString is a built-in method that converts your array into a string. So you can say my array inside the parentheses. So inside your print statement, you say arrays.toString my array. And now if I run it, now you see it's full of zeros. So when you create an int array, the default value that all the variables contain is 0. Why don't you try that same thing now for the names array and see what is the default value for a string. Okay, let's try it. So here's names. Let's run it again. So here are the zeros. This is the nums my array. Here null. Null is the default value for a string when you first create it. And we'll talk a lot more about null as the year goes on. So this is, you got this. Names array contains 100 strings and they all initialize to null. You saw also that you can pre-initialize your array using the curly bracket notation. So here I'm creating an array of doubles called nums that's pre-initialized to these values, or you could do a string array that's pre-initialized to those values. So that's just a thing you can do if you want to make a short array whose values you already know. Okay, storing values into an array works the same way as a regular variable. On the left, you would have the location of the variable that you want to save inside, and then you'd have an equal sign, and on the right would be an expression or a value that you would save inside. So here we're saving 5 inside location 3, and there you see it happening. Notice that you can also have expressions that are inside the square brackets, and this is actually very powerful. So here if I've got a variable lock for location, if I save into lock -1, that would be the location to the left of location 3. Lock -1 would be 2, and so here I'd be saving the number 3 here on the right as a value, but saving it inside location 2, inside index 2. And then on the next line, I'd be saving the number 3 inside, let's see, lock is 3, so 3 plus 1 is 4. So I'd be saving the number 3 inside the location 4. And so you see that happening here and there. You can even access the array inside the square brackets. So array index 5 contains the value 1. So here we'd actually be saying store the value 99 inside the array at index 1, because first we evaluate what is array index 5. We fetch that value, it's 1, and then that 1 gets used as the index for storing the 99. reading values from an array, you've already seen examples of this. Again, it's just like a regular variable, so I could test if array index 3 is greater than 2. I can have arithmetic expressions like this, so fetch the number at location 3, add it to 2 times the number at location 0. So number at location 0 is 2, you see it comes from here. Index 3 contains 5, there it is. I make that addition, and then I save it inside location 2 right there. We've also already talked about displaying an array. Arrays.toString is a nice way to do it. But we'll see again in a second, after looping through an array, you can also loop through it to display all the values. So this is the most frequent thing that you will be doing with an array, is you're going to visit every single location and do something with the value at that location. So you usually use a for loop. I is the conventional loop counter variable. And I refers to a location when you use it inside the square brackets. So let's actually go ahead and type this. So let's pre-create an int array called xvals that contains just some random numbers. Doesn't matter how many. Here's a shortcut, for I. So type FORI and then hit tab. And now don't use your mouse, you will only use your keyboard. So you see the I is kind of highlighted, and I can change it. I can use backspace, so I can type like I or lock, and it's changing in the for loop. Let's keep it as I, but then just hit enter with your pinky. And now you see it's moved to over here. Let's see, there's 1, 2, 3, 4, 5 numbers in my xvals array. So let's say I is less than 5. Now remember, I is being used as a location number. Let's do s out. Element I contains, and then xvals I. So the I goes inside the square brackets. So here so I is just a number. So here I'm displaying like what is the number. But then here, because it's inside the square brackets, I'm using that number to say that's the location that I want to look up the value for. So what this is going to do is it's going to loop through the whole array and display each thing. So go ahead and run it. So element 0 contains 3, 1 contains 6, 2 contains 3. So you can see what's happening there. So that's kind of a nicer way. If you want to see what's inside your array, but you don't want it all in one horizontal list, you want it in a vertical list, you can just quickly write a loop to do it like that. There is a last important thing, though. You should pretty much never be using just a number here to say what's the largest location that you want to loop up to. You should always ask the array how long you want it to, how long it actually is. So you can do that by using the name of the array and then dot length like this. So xvals.length literally tells you how many total things are there. So in this case, xvals.length would equal 5. And you can see that if you want to using a print statement. So s out array has xvals.length elements, and then we can run it again, and you'll see array has 5 elements, and then the loop remains the same. The reason that you want to do this, there's a bunch of reasons. One reason is it's very common to want to change the size of your arrays, and if your loop is hard-coded like this, if I'm going to add a bunch more numbers to my array, all of a sudden the code is broken. And it might be kind of obvious that the code would be broken if all you're doing is creating an array and displaying it. But imagine that this code is, 100 lines away from where you actually create it. It's very easy to forget that this number also needs to change. So here, even though the array is very long, I'm still just looping over the first 5 elements. However, if I were to say xvals.length, it will, like right when you start the loop, it asks the array how long it is, and so it will always do the right thing. It will always loop through the entire array. So that's one reason. Another reason is that you might not actually know how long the array is. Like what if the array is getting passed as an input to a method? So here I've got a method called fillArray. The parameter here is called r, and notice the data type is int bracket bracket. So that, in case you were curious, that is how you pass an array as an input to a method. But here, I don't know how long array is because whoever's running this method is giving me an array, and it's probably going to be a different length every single time the method gets run. So what can I put here? I like literally can't put a number and have it work correctly because I don't know what number to put. So the only thing I can do here is ask the array how long it is. So again, that's the total number of things in the array. Quick test of your understanding. What is the last valid location inside the list? What is the last location I can access? Think about it for a second. It is array.length minus 1. It's always one smaller than the total number of things in the array. Okay, last thing. Why don't you pause the video, take 2 minutes, and read through this method and this method. Visualize what's going to happen step by step when the method runs. If it helps you, draw a little picture where you actually have an int array with a couple of numbers in it and try and trace through the code and think what's going to happen. And then say in one sentence of English, what is this method doing to the numbers in the list? What is this method doing to the numbers in the list? Okay, pause the video and then we'll go through a solution. Okay, so let's look at the first one. I'm imagining that my list contains 4 numbers like this. So let's trace through the code. Here where it says I equals 0, let's imagine that I is 0. So what's actually happening is I'm accessing my list location 0, which is 7. I'm going to take that number 7, I'm going to add 1 to it, and I'm going to save it back inside location 0. So 7 becomes 8. Then I go back to the top of the loop, I add 1 to I, so now I equals 1, so now it's pointing here. And then I do the same thing. I take the number at location 1, add 1 to it, save it in the same place. So this now becomes 13. Then I go back up to the top, I add 1, and so on. So if I was going to put this into a sentence of English, I would say this method adds 1 to every number in the list. Okay, what about this side? Let's pretend that this is what my list looks like. When I starts at 0, what we're going to do is we're actually going to access my list at I plus 1. So so when I is 0, we're actually going to access not 0, but 1 to the right of 0. So we're accessing 12. And now we're taking the number 12 and we're saving it into my list 0. So let's actually write this out. So we're saying essentially, my list 0 equals my list 1. And remember, things are evaluated from right to left. So this number gets saved there. So I'm taking 12, I'm saving it over top of 5. Okay, what happens next? So next we go back to the top of the loop, we add 1, so now I is 1. And this line here, my list I equals my list I plus 1, looks like this. So we're saying take my list 2, because that's I plus 1, and take that number 37 and save it into my list location 1. So now we're overwriting 12, it becomes 37. Then we do the whole thing over again. My list 3 gets saved inside location 2. So the 1 gets copied here, and then this still contains 1. So at the end, we've got 12, 37, 1, 1. So in a sentence of English, I would say that it's shifting all the values in the array left by 1. And it kind of makes sense if you think about it, because if you think about these as being locations, for any location I plus 1 is the location to the right. So we're saying take the number that's 1 to the right and save it inside the location that the number was right of. So that process of being able to trace through the code step by step, visualize what's happening with the numbers, and then being able to say in normal English, like what is that code actually doing, that's a really fundamental skill that you'll need to practice both for the AP test, but way more importantly to be a good programmer. But don't worry if that was your first go at it. It is a little bit tricky. It requires practice. You pretty much shouldn't be doing it in your head. You should have a piece of paper out next to you. Just sketch out a little example really quickly just to make sense of it for yourself. Okay, good luck with this week's problem set.